Thanks, everyone. I feel a little bit like the guy at an NBA game that has to wipe the sweat off the floor at the mid game. I'm going to show you code now that you've heard all the interesting things you can do with ego networks. Now, I think my pitch here is that they're, as was mentioned by Brea, they're actually quite complicated to deal with. And a lot of the data management strategies that we use and that are expected in R really are relevant to sociometric networks only and not ego networks. So you have to go through a couple more steps to use ego networks, despite the fact that I think they're used more commonly probably by people who are not as familiar with R. So there's sort of a strange intersection there. This script that I have up here is on the Google Drive. So if you want to follow along, that might make it a little bit more fun. Also, can the people in the back see, or should I zoom even further? I can barely see, so I'm zoomed in very. Zoom in more? Okay. And so go to the Google Drive and grab this. It'll make it a lot nicer for you to follow along. Okay, so what are we looking at here? We're going to pull some of the GSS data, actually some of the same data that Brea showed in the talk, but I actually made it even worse looking so that we can go through some of our some examples here. So if we look at this data right here, this is what this is going to look like. So it looks a lot like what was showed in just the talk that we just saw, which is that you have some sort of identifier up here, and then you have a bunch of variables, and so far so good. We're pretty familiar with this. If you've used survey data, this seems pretty good. So there's one person per row, and then we have some attributes about who these people are. We also have, in this case, how many people they nominated. That would be pretty helpful to use, which is why in this example I'm not going to use it at all. But if you're an actual smart data analyst, you would use this to make sure you have the right number of ties, right? And then we have some columns here. So close 1, 2, close 1, 3, close 1, 4. For those of you who remembered from the talk, these are connections between the alters. These are the altered alter ties. You can kind of think if you pull all of these columns away, this is basically an adjacency matrix most of the time, although I wouldn't rely on that being the case. Sometimes that doesn't happen that way. Let me actually see if I... Okay. Yes. Just making sure we have the right thing here. And then we have some more variables here that with some numbers appended to it. And again, for those who remember, these are probably alter level variables. So what do we need in order to have an ego network data set? You can either use this whole wide data set, but as was mentioned, this is probably not a good idea. You could go with what was recommended, which is have one data set that's sort of like semi-wide, right? So every row is one relationship for an ego. So there's as many rows per ego as there are relationships. Or you could go one step further and you can have 3 different data sets. No panic. 3 different data sets actually makes it a lot easier. And so it's worth the trouble of going through. And obviously, I'm going to show you a way to do it through IdeaNet because this is basically like a veiled sales pitch for IdeaNet. That's like 4 days long, so thank you for being here. We're going to start with one of the data sets, the easiest one to do, which is basically the ego level data set. The ego level data set is just the same as a regular survey data set. So what I'm doing over here is I'm going to grab our data, GSS. I'm going to say, hey, grab all the columns that I know have to do with just ego. And I think all of you so far, I won't have lost anyone. This is still 1 row per person, and we have the characteristics of the people. So this is what you would use if you had a regular survey. You would put this in a regression, so far so good. Now, we get to the interesting stuff. I need to have information about the alters. So in this particular data set, this is our second data set, we need to have 1 row per alter, which is the same data set that Brea showed that was like the correct tidy version. This is what we're going to try to create here, except without the connections between each person. So how am I doing this here? In this case, it requires a little bit of sleuthing. So I'm looking at this data set and I'm saying, OK, I saw that there's a bunch of variables that are called some version of an attribute we care about, and then a number. And that's probably what the alter attributes are. So we see them. They're pretty consistent. There's 5 of them for sex, 5 of them for race. And in my code book that I definitely have with this, and is not on the Google Drive, but you should have the GSS code book, I know that people can nominate up to 5 people. So this is a pretty good sign. And I want to emphasize, I'm not going through this just out of pedagogical reasons, this is what you should be doing. You should be like slowly sleuthing through your data, like looking, taking your time, making sure you understand what's going on. Okay. So I'm like, okay, I'm pretty sure this is right. I'm going to go to my data set and I'm going to say, grab all the variables. And this is a little bit of, if anybody knows regex, who has background in coding, we use a little bit of regex to say, grab all the variables that end in a number and then in a letter right before that, which I notice is the pattern going on here, right? And then what do we have? And I'm also going to say, also grab the identifier of the ego. The one important things in all those 3 data sets, you're always going to want to have the identifier of the ego, right? Whatever column had the number or the name of the person, you want to keep that because we need to be able to connect those 3 data sets together. Okay, so that looks pretty good. So I have ego, and then I have all the variables of the alters. So that looks okay. I'm going through. Anybody notice anything weird about this in particular with this variable here? Future problem we're about to have? Nobody knows this? You all work with data, I'm pretty sure. You see this, you immediately are like, yeah, education 1, so the education of alter 1 is coded as a number. And the education of every other alter is words. In fact, I can already see that there's more than 2 categories. I'm pretty sure there's only 2 categories here. So this is a pretty bad sign for us. Something we should note down as we're going further. So we're going to keep going. But it's a really good idea to like take a look. I spent legitimately hours looking at these data sets, making sure that it's all fine. For exactly that reason, right? Okay. So.
I just want to point out,
yeah.
You can just cross-tab that pretty quick to find that out too.
You can also cross-tab it.
Instead of like literally looking through every single one.
I know, but you know, if you're neurotic like I am, you go through. But yes, that's actually the right answer. You can cross-tab it, make a table, like go through the code book. Like take your time, I think, is the like common. Yeah, take your time. I think.
The answer is not you could. You should, you must, you have to. Go through, cross-tab, match your code book. Like, you know, if you don't know by heart the range, categories, and so forth of your data, start over, go back, and do it again. So yes, so we're breeding neurotics.
It's a healthy trait sometimes, within this like 4 hours of the workday. So, and also the reason I'm emphasizing this so much is that eventually, obviously, I'm going to show you how to do this in 1 click. But IdeaNet is not going to know this problem with your education variable, right? So if you just go ahead and you're like, I just really want to do this presentation, it's due in 30 minutes, I want a nice plot, it's not going to work. So it's really worth taking it slow here. So I'm going to like grab my education here, and for now, because just I want to do this for the example, I'm actually just going to remove education. We're going to take it out. Now we have our alter data. Okay. So now we still have a problem though, right? So we have our alter data. Let's take another look. It doesn't have education in it. It's still 1 row per person. And now if you remember, the way we want it is 1 row per relationship. So there should be as many rows that say 1 here as there are actual relationships that 1 has. Now, the slight difference we have in this data set and why this data set is a little bit poor is we actually don't have columns that tell us if 1 has a relationship with alter 1, 2, 3, 4, or 5. All we have is the variables for alters. And hopefully you never have data that's this bad. But if you do, here's my strategy for it. And I'll show you a strategy with the better version of the data as well. What we're going to do is we're going to take the data, this one right here, so 1 row per person. We're going to make sure it's grouped by ego. And then we're going to pivot the data so that it only has ego in it. What I mean by pivot is to move from a wide format to a long format. So we're going to take a look. And this is all like coding stuff. You have to kind of get used to it. I just want to show you how it looks. This is all. If you're not used to coding, this is all going to seem like gibberish. That's OK. Just take your time, go through the code. But this is what this is going to look like now. So you see the difference? Now this ego 1 has 5 rows. And now the variables that were called like sex1, sex2, sex3, et cetera, is just sex. And we have the values that were in those columns along in that column. So if I move down, let's see if I can see it here. Oh, I did only the first 5 rows. But if I look at ego number 2, it'll also have 5. Okay, so what's the problem here? Yeah.
How do you know that the information about each alter is associated with the correct alter? Like before it had, I knew it was alter 1's sex, alter 1's race. Like,
Yeah.
how can I know this is right?
It goes back to being so familiar with your code book that you like dream of it at night, right? So in this particular case, I know from the code book that sex1 is the variable sex associated with alter 1. So what I did, and if you want, you can do what's nice about this tidy way of coding, is you can take pieces of the code. So if I just take this here, and so now what I'm doing is I'm highlighting this piece of code and I'm pressing Command Enter, which will only run these 4 lines of code, right? It'll give me the output. This is kind of what it looks like in the middle. You can see I already have my egos all the way down and my variables here on the side. This is kind of our middle ground. And so what I'm doing, this is the trick that I'm actually doing in this particular case. There's lots of ways that you could go about doing this. I'm splitting the 1, 2, 3, 4 into its own column, and I'm calling it alter ID. And then eventually I'm going to pivot this wider, which is weird because we said we wanted a long data set. I'm kind of half pivoting wider, just those particular things, so that we can get this variable right here. Again, if you don't understand the coding bit of this, it doesn't matter. You can go back to this. You can take your time. You can use that trick where you highlight some code, press Command Enter. It's just a matter of practice with that stuff. OK, I only did this, though, with the variables that were numeric. So I want to do this again with the ones that have words in them. So we're going to do that. And then I'm going to combine them together. And then finally, we have something that looks like a data set that we want. So reminder, we have our first data set that was the ego data set, 1 row per person, and it had their attributes. And then we have the alter data set, which is 1 row per alter, nested in egos. So far, so good. If there's questions, this is not like a lecture. Please jump in if there's any questions. Everybody's like, I have no idea what you're talking about. OK, so we're 2 data sets in out of 3. So let's move on to number 3 here. Oh, I missed one thing, actually. That's pretty important. OK, so in this data, reminder, I pivoted. So now everybody has 5 connections. Does that sound right, necessarily? Like, I know that some people in this data set maybe nominated 4 people. In fact, I know that for a fact because we did the ego data set. Let's go back to it here. Go here. Here's our ego data set. I had this num given variable, and this tells me how many people got nominated. 4, 6, I cut it to 5, so don't worry about that. But I'm saying, like, OK, this is the number of connections that you can have. I, right now, pivoted it so that everyone has 5 connections. Let me scroll down. This is live coding, live showing. So the way I'm going to do it here is I'm going to use some strategy to remove some of those connections. Some of those connections are not actual connections, but they're rows in my data set, so I want them out. The way I've decided to do it is if all the attributes of the alters are NA, they're empty, I'm going to say that's probably not a real connection. Is this a good idea? No. OK? So for the sake of example, it works, because GSS is a pretty messy data set. But again, cannot repeat enough, you should have a real like strategic, educated way of doing this that is not just, if it's empty, it's empty. Okay? But that's exactly what I'm doing. OK, so the last data set, we have ego data set, we have the alter data set. Now we need like one last data set, which is the connections between the people themselves. OK, so let's go back to our data real quick, and I'm going to say, Matt, give me all the columns. Ego ID, always give me ego ID so I can connect those 3 data sets. But also all the columns that say close in it. And I know that from my code book, those columns that say close are the ones that tell me whether or not people are connected, right? And the way that works is that this column says person 1 is connected with person 2, whether or not person 1 is connected with person 2. Person 1 with person 3, 1, 4. You'll see that not all of them are there, and that's because it's an undirected data set, right? And these values here are so strongly connected they are. And just to give you an example of like how I showed you that the middle of the code thing, instead of splitting it into one column this time, I split it into 2 columns. You can see that piece of code that I used earlier. I have 2 of them now, and I created 2 columns from 2. So if you're interested in how I decided to do that. And lots of coders in the room are probably like, this is such the wrong way to do it. There's no good way to do it. There's just the way that might work for you.
Sorry, why did you do that then? Why did you have like 2 columns?
Okay, yeah, you're right. I went a little fast on this one. So what is the alter data set? How should that look like, right?
Oh, okay, so you're splitting the connections again.
Exactly, yeah. So every row of the alter data set should be a connection between 2 of the alters, right? And then, so there should be as many rows as there are connections between the alters. Well, let's take a look at how that looks like. Right, so any questions of where we're at with this?
So I have a question about the 2 column there.
Yeah.
So this is, I'm seeing that like ego 1
Mhm.
has said that they have a connection like over to alter 1 and alter is connected to alter 2. Is that right? Is that what I'm reading here?
So this is saying that in the ego network of your respondent number 1, their first nomination is connected with their second nomination. They've said, hey, the first person I nominated is connected with the second person I nominated. This might seem a little confusing, but I swear it's worth it in the long term. Usually you repeat, so the ID of the alters is repeated every time you move to a new respondent. So let's say that we all do an ego network survey, right? We all are asked to nominate 5 people. Your first respondent will be alter 1, right? My first respondent will be alter 1. All our first respondent will be alter 1. So that it repeats like this. So if I go down to number 2 here, we have the first row of number 2. Their first respondent is also number 1, number 2. So it seems a little complicated. You think, oh, maybe we want unique alter identifiers, but that's actually not programmatically worth it.
So then in this case, thank you, that's helpful. Ego 1 has said they have a connection to alter 3, but they haven't mentioned alter 4 yet. Alter 3 has a connection to alter 4.
So to be clear, ego is always connected to all the people they mentioned by definition, right? So they've nominated 5 people in this case. Or sorry, they've nominated 4 people in this case, actually. We removed one of the people, right? And they said, then they were asked, are these people connected with each other? And this is what we're looking at here. So they're actually all connected to each other except for 1 and 4, what you can notice here. No, don't be sorry. I can assure you that you've asked the question that like 19 people in this room had. Any other questions?
Going off of your idea,
Yeah.
like way more basic. So this ego ID is really the ID of the alter. This
So-
is all alter.
No, ego ID is always the identification of the respondent, of your respondent. So whatever data we look at here, so let me just pull them all side by side. There we go. Well, if you're doing ego network analysis, right, you always have the respondent. So here's our first data set here. This was our ego data set, right? And we have that column ego ID. Sorry, this is our alter data set. This is our ego data set. And we have our first column here is ego ID. This is how you identify this was the first respondent I interviewed. This was the second respondent I interviewed. Then you want to know about their social connections. So it makes sense that you would also need their same identifier so that you can connect it back to this one. That's like their name, if you want, right? Like if you were interviewing people, you might identify, usually you want to identify them by a numeric, like a number for, anonymity reasons. So they're here, and this makes a lot of sense because they're connected to their different alters. The one where it makes a little bit less sense is in the alter data set. You're like, oh, ego's not involved in some way. I guess you could get away with only these, but then you wouldn't know which ego network it's related to. So now you see that ego ID is in this one, it's in this one, and it's in this one. So then we can match them all together. It's not basic at all. It's not basic at all. In fact, do we have enough time to? Yeah, let's try this. For all the people who were like on iMessage, not paying attention. I see you. Okay, why don't you find a dyad or a triad, so a person next to you or two people next to you, and try to draw, don't even do it in code. If you have the notepad next to you, just try to draw what the 3 data sets should look like here. Just try this for me. This is basically like exercising this brain, and I think it's really, really useful. Because I just went through it, and you just probably went like, I have no idea what he's talking about. This is going to exercise like this exact same thing I just did, but try to do it in pairs or in trios. Just draw it on a piece of paper. Do like for like 2 minutes. I'll give you a couple of hints. This T here means that they're texting, and this F means that they're face-to-face connections. And this is self-explanatory. These are romance connections and friends. Another tip I'll give you is that the alter data set is like going to be a little different from the one I showed. There's like a trick here. But the first 2 should be the same. And in like 2 minutes, I'll ask you what you think. And that way we're not looking at code the whole time. Yes? Sorry, I didn't account for the people without a team. Face-to-face connection. T is text connections. Okay, 30 more seconds. T is text connections, texting. Face-to-face connections is F. Okay, guys, let's give this a shot. If you're not completely done, that's okay. We'll give it a try. I love this because you know there's a selection mechanism. All the people in this room, you give them something akin to a test and they're like, I got this. I know, we're all the same, folks. All right, guys, we're gonna see. So what do you think the ego data set looks like? This should be the easy one everybody got. So what column should be in the ego data set? Should probably look like this. Okay, so you got that, you're good? This is pretty easy. So one row is one person, and then we have the columns that have to do with the ego. Why? It's very likely because there's no sort of identifier on the side of this column, so probably ego. Okay, so harder now, what should the alter data set look like? Yep. And then what about the alters? How do we identify them? Okay, so it should look something like this, right? Still have your ego ID, the absolutely crucial ego ID, right? And then we have the identifier of the alter. And in this case, if we go back here, right, there are only 2 kinds of alters, pretty easy. So we have 1, 2, 1, 2, 1, 2. And then it said the underscore F and underscore T, which were face and text connections. You can think of those as like the weight of that relationship. If it says NA, there's none. Now, if it says 0, maybe there's none too. So this is something else you need to like reference the code book about. Maybe it's not always NAs that are not ties here. So there's 2 kinds of connections between the ego and the ID. Sorry, the ego and the alters. And then there's also the sex and the race of the alters. Did anybody notice anything about the sex and race here? Let me go back. There's going to be a problem once we merge all of these together. So merge the sex of the ego is numeric, the sex of the alters is. So if you notice this, you're already data brain. Okay, so what should the alter edge list be? Yep. Should it be alter ID? From to. Now, here's the trick. This is different because there's 2 connect. So here's ego 1, and they have 1 connection between 1 and 2, and it says romance. Person 2 has 2 connections between 1 and 2. One that's NA, one that's friend. Person 4 has 1 romance. Person 6 has a romance and a friend. This is different from one we just looked at. And that's because in this survey, that I just totally made up, people could say, the two people I nominated, they're friends, or they're in a romantic relationship, or there's none of them. I want to go back. This is what was going on at the very end there. This is why this was a little tricky. So now your alter data set has one row per connection, duplicated if they have multiple kinds of relationships. Again, person 6 here, there's 2 connections between 1 and 2, and they're both friends and they're romantic partners, right? These people are just romantic partners. They're not friends. They hate each other. So this is a bad marriage at the top here. Does this make sense? Is this helpful? So this is exactly that thought process. I actually do it by hand sometimes. Yeah. Nice. Nice catch. So this tells me, so I only kept, by the way, here with the imaginary code that I have, I only kept the relationship where it said true. But I kept the one that said NA, because my code was made so that it would only take the ones that say not false. And I say, oh, NA, that must be something. But what if NA is just badly coded false? I don't know. What if it was actually a different kind of relationship and it got removed by some secondary coder? So nice eye, because you want to be careful for that, right? You go back into the code book. You email whoever you got the data from. You know, the suffering continues. I'm really selling this so well. This is really, it's fun. You know, like 10 hours in. Okay, so let me show you. So you've gone through all this. You've done it. I think it's really important to know how to do all these things. We've got 10 more minutes. This is actually how your data will probably look if it's in wide format. Don't worry. It will probably have something like ego on the side here, so the people that were interviewed. It will say, hey, this is the variable associated with ego pretty clearly. It'll have the name of the people. This is the columns of the connections that they have or don't have with different people. This is what we were missing in our example. So this is saying, hey, Mary's connected with Tom, Vicky, Leanne, Joe, et cetera, et cetera. When it's NA, it's going to be empty. If we keep going here, people could go up to 18 names. And here are the variables about each alter with their number by order, right? So this is saying sex 1 here is associated with the first alter that was nominated, which is Tom. Okay? I think that's fake data got messed up somewhere there. And then you'll have eventually a set of columns, which is similar to what we looked at, which is saying, and these 2 connections are connected together, right? So we have our connection 1 and 2, they're not connected. Connection 1 and 3, they are connected, et cetera, et cetera. So hopefully you'll get your wide data in this format. This is the dream. If you do, we have a function for it. And if you just fill in the right variable attributes, which is basically saying, hey, what is my data? What is the name of the ego ID, right? Because this is what's going to connect them all. What are the variables associated with ego? What are the columns that tell me which connections ego has? What are the columns that tell me what the variables associated with alters are, et cetera, et cetera, et cetera? I'm going to hit this, and then look, my first data set, ego data set. My second data set is the alter data set, right? And my third data set is the alter data set. 2 ways to approach this. 1, you can take your really, really dirty data that's wide and turn it into cleaner wide data and then run it through this. Or you could turn it into the long form the way we just did it manually. Both are perfectly valid. Sound good? Okay, so we have our 3 data sets. What do we do now? We haven't even built a network yet. I mean, it's there, but we haven't built a network object yet. Like Brea mentioned, the thing that's difficult with R is that the packages are developed really for sociometric data. So you can only really create like one network that expects all the nodes and all the edges to be in it. But really what we know we have is like 1,070 individual small networks. So what we're going to do here, just for example, is I'm going to say, give me my alter data we constructed and the AA data. And we are going to create a network object the way that we've been doing in previous tutorials using graph from data frame, create an iGraph object. Oh, AA, sorry, let's say alter. That's how I named it. So I named ego data, the ego data set ego data, alter data was the alter data set, AA is alter alter. I have an aversion to 2 underscores in the names of my objects. And here's our data set. So remember, the only connection that was missing was between the first and the last alter. Now, we're obviously missing one person here, which could be okay. So you can do most measures from the iGraph object without ego in it. But sometimes you want to have ego in it, especially for pictures. And so what I'm going to do here, and this is pretty simple, because what ego is adding a node and then saying connect it to everyone, by definition, right? Otherwise, a node wouldn't be in there if they weren't connected to ego. So that's exactly what I'm going to do here in this code. And again, tell me if you want me to go through, we're not going to worry about that. Tell me if you want me to go through slowly the code, but it feels to me like it's easier for you guys to go back and like understand what it is, right? So here we are. So we have the picture with ego in the middle. So not bad. Okay. Yes, the one thing we're missing here, I might jump this for time, is you also want to bring the attributes of ego back into the network, remember? So we added a node in there and said connect it to everyone, but it doesn't have any of the attributes that were originally associated. And so what I'm doing here is I'm bringing back the attributes. And I'm just going to do this. And so now we have ego network the way that you might want it, right? So we have ego up here, and we have nodes highlighted by what sex they are, which is a variable we had for both alters and the ego. Yeah? Yeah, I might have jumped through this. So in this case, for example, I'll go back up here. I pulled out one of them. I said, in the alter data, right, which has the core, really, connections between the ego and the sorry. It's basically the node list of your alters, if you want to think about it that way. I said, grab only the ego, the first ego, the person who has number 1. And then here, in the alter data, which is our edge list in some ways, I said only grab the connections between the alters of ego 1. No, so this is to show you could do it one by one. This is how you would do it, right? They're all little networks. They're all like little node lists and edge lists that you can pull out one by one and create this picture with. But this is not very practical, as we'll see, obviously. Yes? Your question?
So, example, 1, 2, 3, 4, 5, or I want to get a table 1 to 20.
You could if you're very confident with working with, like, applying functions to lists, which, if you're a beginner with R, you're probably not. And so that's why this is pitch number 2, or like 18. So before we do IdeaNet, there is a package that has existed for a while, way before IdeaNet, which is called Igor, and that will do this work that you're describing. So it'll take all the different egos and it'll create one object that has all the ego networks in it. And so all you do is you give it the data that we created. Remember the ego data set, the alter data set, the alter data set, and some information about what it should look for in those data sets. And then it might take a second. And by default, it will plot the first 4. So here, reminder, this is what we plotted manually a second ago, is this first one. I think their default plot looks a little uglier, but that's personal. Okay, alternatively, you use IdeaNet. And the reason we didn't like this as much is because you have to work with the Igor object directly and ask it for specific measures. It's not as easy to pull out individual pieces, right? I mean, you can, but it's not as straightforward. So EgoNetWrite is the equivalent for ego networks that NetWrite is for sociometric networks. And so I'm still using, there's a lot more arguments here, but I'm using the same 3 basic data sets is what I'm trying to show you here. So both of these functions expects the 3 data sets that I talked about. The ego data set, the alter data set, and the alter data set. And so I'm going to run this. It's going to take just a second. And then the second line of code that's going to appear is I'm saying, grab me the first iGraph object, grab me the one that has ego, and then plot it. And I'll show you a little bit more of what this outputs once it's over. It's going to give me a lot of warnings. But basically what this is doing is what you were describing. It's saying, do the same work of creating the network for all of the individual little networks. And so here we go. We have that exact same first ego network, right? Let me just show you kind of what this creates. There's lots of ways, but if you go to, so I saved it to res here, and this is very similar to netwrite, so I'm not going to go over all the outputs, but just to give you an idea, it'll give you your egos. So this is what we put in there, right? This is the ego ID and then the variables associated with ego, but then maybe more, and it'll give you the alters as well. So this is your same alter data set with the changed IDs, the way that Tom explained, so that they're indexed at 0 instead of 1, which is a little bit specific problem having to do with iGraph. But this is the one that you probably are interested in, right? If we go to summaries, now we have, for each ego, information about what the ego network is. Summaries about the ego network. How big is the ego network? What's the average degree? What's the density? On. And you'll start seeing some names here that came up in Barry's talk. Fragmentation index, constraint effective size came up. So all of this is being calculated for you, right? And then a triadic census. So this is the equivalent of the output from netwrite that was long, that said like, this is everything you need to know about the network. It's that, but in the other direction for each of the ego networks. And then if we look at overall summary, this will actually give you information about the aggregate. Let's see if I can, there's a lot of text here. But like, I'll move here. Things like how many ego networks there are, how many, alters there are, et cetera, et cetera. So it's sort of a summary of all the ego networks together. I think, so this is amazing, that's great, because it does your work for you. The one feature that I really love about this is this right here. This final one says iGraph object. And if I pick the first one, it's a list, it'll give me a couple of pieces. It'll say, for the first ego network, give me the plot with ego in it, or so the iGraph object with ego in it, or the iGraph object, so you see 5 nodes and 9 ties, or without ego in it. And so this is what we're going to use if you want to pull it out and you want to do your own measures using iGraph. You can just pull one like this. Yep.
That's from ID in that?
Yep. Okay. And so if we wrap plot around it, right, this, which is what I did just above, this is the one without ego, and then this is the one with ego. And you can also look at some information about ego specifically. Just pull out basically that row from the first thing I showed you. How much time do we have? We're over time. So if you want to keep looking at the script, I did not get to this, but IdeaNet will also do specific measures that have to do with characteristics of the people in your network. So I'm going to scroll down here a little bit quickly. Trust me. You can go through the script. I just wanted to show you some of the things we can do here. So for example, they were talking about the H-index and the IQV. One way you can do it is do it manually from the alters data set, which is, I know how to do this. I know the math behind IQV, kind of. Don't tell professor. But I can also grab the function from IdeaNet and it'll calculate it for us. So you don't need to use the entire, you don't need to write out the math yourself. Okay, so there's other stuff in this tutorial. If you want to go through it and ask me questions, I'm around. You see me, I'm in the blue shirt. Thanks, everyone.